I'm Laura DeLuca, a PhD student in English at Carnegie Mellon University studying early modern drama, book history, and digital humanities. At CMU Special Collections, we have a wealth of interesting material to analyze, including copies of each of Shakespeare's folios, which are currently on display at the Frick Museum here in Pittsburgh, Pennsylvania. We are also currently running an exhibit on the Print and Probability Project. Let me take you through it. The Print and Probability Project team, which began here at CMU, is composed of book historians, statisticians, computer scientists, and librarians who solve bibliographical mysteries by modeling the material conditions of early modern print shops, including typepieces and fonts, paper, inking, and imposition. This is a demonstration of the type of work that our project engages with.
One of the several tools we have developed together focuses on the color of paper, which offers insights into how early modern books were constructed. This accessible research tool uses details from online rare books repositories to let us examine the color profile of every page in the book. Why might we want to know more about the color profile of every page in an early modern book, you might ask? We can discover things like if a book was printed in 2 different print shops, if a book was printed across 2 different eras, or even if someone inserted some illicit sheets after it had passed the censors. Let me show you how it works. This is our interface, which is called the Coloring Book tool. First, we must plug in the IIIF manifests of books, which can come from repositories such as the British Library, Cambridge University, Folger Shakespeare Library, Harvard University, the Harry Ransom Center at UT Austin, and Internet Archive. A IIIF manifest is a metadata file that contains information about digitizations of early modern books, which allows us to interact with them through IIIF compliant applications like this one. I'm going to be entering the manifest for CMU's copy of Thomas Hobbes' Leviathan. After entering the manifest, you'll see a page that matches a random sample of your book's pages together. This is totally normal. The purpose is to help you find a spot in the resulting image that's just paper containing no text. The thought is that a blank spot on this composite image likely means that few or any pages in the volume have ink or discoloration covering the paper. This will allow us to accurately read the color profile of each page. Then, we'll use our mouse to draw a small rectangle in a region that is likely to be blank on most pages. What'll soon happen in the background is that it'll calculate the average color at these coordinates on every single page in the book. So you want it to be as uniform as possible. The next step is an optional filtering step. Maybe there are binding images or end paper images you don't want. Or maybe you've accidentally captured a catchword or a signature mark. These will throw off your averages. You can delete or modify your rectangles one by one by clicking the delete button or the edit button on an individual image. While not 100% necessary, doing so will allow you to have maximum control over your result. Then, we're going to click Extract Color Information. This will display a plot of the aggregate color in each rectangle from the previous step by page number. Colors can be aggregated by either mean or median. The median can be a good choice if you want the average color to be robust to small outliers, like bits of text that might have crept in. We display the color in the standard RGB color space, as well as a more perceptually uniform LUV color space. It might be worth examining both to see what patterns stand out. If you highlight a point, you can read off the specific value associated with that point. You can also click a point to view the page from the book that it represents. This can be useful for figuring out exactly where you are in the book or for checking for aberrations. With this tool, we are able to see that CMU's copy of Leviathan contains multiple paper types. Through using this tool, we can see that this book uses 2 main stocks of paper. The first stock of paper, more common in the first and final third of the book, but appearing throughout, is lighter in color and tends to have brown flecks on it. The second stock is darker than the first stock and is in the central gatherings of the book. There's also a third stock, but it is used for the frontispiece. The likeliest explanation for the pattern is that all of the fonts and paper were housed under a single roof. The arrangement of these paper types suggests that this copy of the Leviathan was printed at a single print shop. The last step when using this tool, if you so choose, is to download your data. The tool doesn't store any of your data, which is a good thing if you're concerned about privacy, but it also means you won't be able to come back to this set of rectangle sections. Downloading your data is the only way to retain and document your results. If you choose to download your data, you can open it in Excel and get an organized, detailed view of those values we were just examining. You can also locate the specific pages you were looking at and open them in a new window. Are you interested in reading more about our Leviathan findings? Or are you interested in seeing the type of research that can be done with this tool? Check out our article, which will also be linked below.
On behalf of the Print and Probability Project team, we hope you enjoyed learning about our tool.
You can access the coloring book tool for free via the link in the description below. Are you able to solve a print mystery with our tool? We would love to hear about interesting examples. We'd even love to use some examples in our papers, giving you credit, of course. If you find something cool, let us know. You can tag us on Twitter at print_and_prob or email us at cnwarren@cmu.edu. Do you want to learn more about what the Print and Probability Project team does? You can find our website here as well as in the description below. Thanks for tuning in.